And hi, welcome everyone to this OpenFOAM video. Okay, looks like it's working. All right, so in the last video, we're talking about snappyHexMesh layer addition. Of course, now we are looking to smooth out this mesh. We already know how to separate it out into the top, bottom patch, etc., etc. Oh, I just did a clean case on this one. I'm just going to start from scratch. All right. Yeah. So we're going to do a free cat. We run our mesh again. And before I continue, just want to give you an overview. Okay. So we want to talk about getting our we want to talk about smoothing out the surface edges. Okay, now I got a new one. Let's use surface with edges. We want to talk about refining these bits near the surfaces because they're looking pretty blocky now. I want to do something about that, and we're going to talk about explicit feature snapping. Okay, we have been using the implicit one because that's a very easy one to use. You just turn that on, and you know the sharp angles. Okay, the sharp angles here will be resolved. If you don't turn it on, then let me just demonstrate just to refresh your memory. snappyHexMesh dictionary. Let's see, implicit feature snap. Where is it? Let's see. Castellated mesh control, explicit edge refinement. Let's see, refinement regions. Nope. Snap controls. Yes, implicit feature snap. Okay, if I make it false, this is what will happen. Just to refresh your memory. So I'll move F5 and you look at that. The surfaces here will be very ugly. So what usually we can do is either we do the implicit feature snap. Okay, we can do an implicit feature snap, or we can do the explicit feature snap. Okay, so you know what that does already. So I want to demonstrate the explicit feature snap because that is way more versatile than the implicit feature snap. Gives you more control in general. So to do that, basically we need to have an external file, an object file or emesh file that captures all the sharp edges, so to speak. Okay, it captures all the sharp edges. So hopefully that explains why we are doing that. All right. So if you're not sure where to find it, you can go to OpenFOAM installs, go to the flange tutorial under snappyHexMesh. Again, if you're not sure where to find any of these, you can do a grep r of surface feature extract. Okay. Surface. Okay. Feature extract. Maybe I made a typo. Yes, I did have a typo. So where can you find it? They will list all the directories where you use it. There are a lot. You can just go for the one that says snappyHexMesh. Okay, that will be under flange. Okay, so you go to the flange directory, the mesh, snappyHexMesh flange. Okay, and there you will be. Take a look at the all run files to kind of see what they're doing. They have this, they basically copy over a flange STL and just put it in a tri-surface, which is quite, that's what you need to do to put the STL file there. Then you run block mesh. Then after that you run this thing called surface feature extract, and let's see what that does. Okay. Let's see. We can run the first three by doing so. I'm not going to change this file here. I'm going to copy this all run into modify mod run. This is our own custom all run file. Let's do that. Let's go and change. This first tool, I'm not going to do too much. I don't want to run snappyHexMesh just yet, just these 3 files. Let's see what happens. Oh, right, it's a bash file. I can't use this. Yeah, I'll have to use a pound sign instead because this is a bash script. Okay, let's do a mod run. Okay, so there are just 2 things that came. Alright, so we look at the log.surface feature extract dictionary. So what do you see? Blah blah blah, feature line extraction only valid on closed manifold surfaces. So that means the surface must be closed. We cannot use this wall, bottom patch and top patch because these are just open surfaces. Alright, so you'll be reading the surface feature extract blah blah blah, and then it will write. You will write it to the constant extended feature edge mesh flange flat edges object. So where will it write it? Go to constant and you go to extended feature edge mesh, and you'll see a whole lot of object files there. Okay, a whole lot of object files there. Then what does the snappyHexMesh do? Let's check out their dictionary. Okay, vi system snappyHexMesh dictionary. Alright, so you go down in your geometry, you'll have there, it's pretty standard, nothing too much. There's this refined hole there, which is basically a sphere. Don't bother too much about that. So we have an STL file as usual. Castellated mesh controls, most of it's the same. Okay, most of it's the same except this part. It says explicit edge refinement, and then it goes for this thing called features. Then it will look for this file called flange extended feature edge mesh. So let's take a look and see whether this flange extended feature edge mesh is anywhere to be found. So you can go to try surface, and so you see this flange emesh is here. Okay, so that's where you'll find it. Okay, so that's a surface feature extract dictionary. Alright, this is what we are doing. Extraction method is extract from surface, and then you include angle, means to say anything below 150 degrees if your edges, so to speak. I mean, you see this as a cylinder here. The angle between this flat surface and the other sides, that's like 100 degrees. I mean, no, 90 degrees. Sorry, 90 degrees surface. All right, it's a 90-degree surface. So if the angle between this edge and this edge, which is the wall, exceeds, I mean, it's below 150 degrees, the edge will be recorded, so to speak. Alright, so basically that's what happens. If you take a look at snappyHexMesh dictionary here in this one, the tutorial file, you'll see the flange.emesh. I mean, this I guess is the old way of writing. Maybe you should write flange.emesh down there, and then you can specify a level of refinement for that. Okay, then the rest is pretty much the same, and you'll notice something. That when we talk about let's see, the mesh quality controls, okay, take a look at this. It says explicit feature snap is true. Alright, and then you also can detect features between multiple surfaces. That's the multi-region feature snap. If you want to turn that on, it's okay, but it's not always necessary in this case, unless you're using this for multi-region case. Most of the time you can just turn it off. So how does this apply here? Well, I can run a surface feature extract here. Alright, let's copy the dictionary over. Let's see. I don't need to copy the dictionary, so okay, maybe I'll just do it. Alright, so let's see. Let's go to system, and let's see how much time I have left before I talk too much. 10 minutes, okay. let's see, copy what file, blah blah blah, OpenFOAM install, blah blah blah, system here, and I'll paste this. I'm looking for the surface feature extract dictionary. Okay, flange, oh right, it has to include the squiggly line there because that means the home directory. If I leave it out, you'll think it's coming from the root directory in Linux. So surface feature extract dictionary, I'll paste it here. Let's go to surface feature extract dictionary. So what am I looking for? I'm not looking for flange.stl anymore. I need to look for the complete cylinder. So what's the cylinder name? Okay, go to try surface and you ls try surface. You'll look at this. You look for this thing called begin cylinder.object. So I'm going to copy that and paste in here. System surface feature extract dictionary. Oopsie. Quit. Okay. Surface feature extract dictionary. Okay, and I'll paste it here. So I'll write that in, and I'll say, yes, let me extract it from surface. So surface feature extract. Okay, so it happens really quickly, and let's go to constant, and we see the same extended feature mesh here. Alright, all the object files are there, which is great, and we go to try surface, and we see that the begin cylinder.emesh is over there. So copy this, and let's go to the system snappyHexMesh dictionary, and we'll paste this emesh file into this place. All right. Okay. So this will be the file inside the try surface. So it's a begin cylinder.emesh. Okay. We can change the refinement level as we go on, but I'll just leave it as 2 for now. So let's run let's rerun everything. Okay, and this time I'll want to actually run application surface feature extract, and okay, since I'm already here, might as well scale it down even more. This is what I wanted. Okay, so let's move it and do a FreeCAD mesh gen. So it's done pretty quickly, and let's take a look. I think did I turn the snapping on? Yeah, I need to make explicit feature snap true. Okay, so I need to rerun it again. So I'm going to do the FreeCAD style mesh gen again. The script's going to run pretty quickly, and yeah, that's more or less it. Okay, so that's basically how it works. Unfortunately for this kind, it doesn't really do very well here. Okay, so let's turn refinement off. So, but you can see it gives you a lot of control. Oops. It gives you, I guess, more control over what you're doing. Okay, let's turn the refinement off for here. Okay. It gives you more control on how much you want to refine the surface. Okay. Okay, let's do that again. Apply. Okay, it's still a little iffy. So there's some things we need to do to actually get this thing to work properly. But you kind of learn more of the behind the scenes work over here when you do such things. Okay. Right. Then let's see. Yeah. So let's try and debug this. Again, this one looks a bit iffy as well. So let's redo some things. Let's turn the add layer step off so that we can sort of debug what's going on. Okay, FreeCAD style mesh gen, and reload. Okay, nothing happens. Okay, so let's adjust a few settings to see whether it helps. All right. So what I'm thinking now is, probably the edges need some refinement. Okay, the edges need some refinement. Okay, you see the second is the maximum refinement level. The cells that see multiple intersections will be refined. That means at the sharp edges, these cells will be refined a little bit more. So let's put it at 4. 2 and 4. Okay, 2 and 4. Okay, that's how we can do it. And let's run the full mesh generation again. Hopefully it gives us a little bit of a better result. And look at that, it's more nicely refined now. No doubt that it only applies to these edges, but most of it actually works pretty well. So we can maybe leave it at level 3. Okay, BI system snappyHexMesh dictionary. Let's put it at level 3 so that, yeah. So this is an explicit feature refinement. Let's do a free cast style mesh gen again, and we should be able to see better results. And yeah, generally this is a much better looking mesh. Right, this is a much better looking mesh than what we had previously. Okay. And if we kind of draw a straight line through the center, slice plot, yeah, and we'll give it surface with edges. We see that in general it's pretty much nicer than what we had before. If we want, you see this in the center, we have lots of blocks. We'll probably want to make that refinement a level 3 refinement. So that the cells are a little more even. Okay, so this is what we are doing to fix things up. I mean, looks like the 3-3 setting actually works well. Okay, but this is how explicit feature refinement is done. You can do it for internal as well, but if you learn the external method, you have a bit more control over what's going on. Okay. So here it says specifies a level for any cell intersected by edges. Okay, you can increase the refinement if you wish. Let's just put level 5, and we can see what. Okay, I'll put a level 0 first, and then we'll put a level 5. We'll see what changing that level will do. Okay, so here we have a 3 and 3, so to speak, kind of a mesh. Okay, let's reload. Okay, snap is lagging. Let me close it. Force quit. Thank you. I think paraview. Should just delete next time. All right. Let's do refined again and put apply. Okay, it's a very nice smooth surface this time. Surface with edges. Look at this. This level 3 actually makes it nicer. Okay, but of course that means there are a lot of more calculations you're supposed to do. The mesh is fine. Very fine. A bit too fine for my liking, in fact. But okay, it works. Alright, so slice. And okay, so we see that near the edges we have like what do you call that? Level. We have finer, blocks in the center. We have finer blocks in the center. Alright, finer blocks in the center, but also finer blocks near the edges. Alright, so if that works, that works. It should result in a nicer mesh shape now. So okay, so that's the explicit feature edge refinement. We can turn back on the add layers. Okay, we turn back add layers to true, and let's see. It's a very fast. So let me delete this. I don't want it to lag on me again. Okay, it should be done. Yeah, it's done. Okay, surface with edges, and now you see, look, we got a very nice looking mesh over here, and we have the layers that we want. generally speaking, it should be okay. We do the slice plot and let's do a surface with edges. We shall see this sort of surface over here. Is there anything we can do about all these strange shaped cells? Well, that's I mean, if if we don't adjust the mesh quality, there's nothing much we can do, but we can of course tweak it. Yeah. So this is generally like the mesh that we kind of want. We may want a coarser mesh for more stability next time, but as of now, this is what we are left with. So yeah, you see these things are so small. I don't really like too small meshes. I mean, they generally contribute to more instability. But anyway, thanks for watching. I'll see you guys again. We can talk about other subjects next time. But for now, you know how to do surface feature refining, and you know how to control the mesh quality. I mean the parts a little bit more. This is another way to deal with these sharp corners and edges. Okay, thanks for watching. I'll see you guys again. Bye bye.